In this question, we're asked to complete the following table where, given the subshell, we find the principal quantum number n and the angular momentum quantum number L. So, as a reminder, n is the principal quantum number, and it can be any integer from 1 to, in theory, infinity, but it has to be an integer. L is the angular momentum quantum number, and it's 0 to n minus 1. M sub L is equal to the magnetic quantum number, and it's negative L through 0 to plus L. And M sub S is plus 1/2 or minus 1/2. So these are the 4 quantum numbers. These are kind of like GPS coordinates for electrons. So a person has a latitude, a longitude, an altitude, and a time. An electron has an N, an L, an M sub L, and an M sub S. So if we look at these different subshells, they have these quantum numbers. Now they don't all have all 4 quantum numbers. You can only get 2 of the 4 quantum numbers from this information. But n is given. So 4p, n equals 4. 5d, n equals 5. 2s, n equals 2. And 6s, n equals 6. So this is n. As far as L goes, L equals 0, we call that an s orbital. If L equals 1, we call that a p orbital. If L equals 2, we call that a d orbital. And if L equals 3, we call that an f orbital. So L of 0 is s, 1 is p, 2 is d, 3 is f. So 4p, a p has an angular momentum quantum number of 1. A d has an angular momentum, or an L value, of 2. An s has an angular quantum number of 0, angular momentum quantum number of 0, so L equals 0. And another s is 0. So this little table here can tell you how the subshell with a letter designation relates to the quantum number, which has a numerical designation 0, 1 through 2, and 3.